Newton's bench, lab number 6, conservation of momentum collision. And momentum is conserved, and kinetic energy is also conserved in an elastic collision where everything bounces, and which is what we're going to be doing here. You notice I have the setup here, the ramp with the collision holder there, and we're going to do a collision and measure where they land, and then you're going to do one without the ball in place and measure where that lands. Like so. So you have a collision, and the execution of where both those balls lie versus where one lies without any collision. The momentum, P is equal to mv in both directions. In the x is equal to mv equal to mv in the x and mv in the y. Well, if the masses are the same, we can cancel those out. You notice now that all we have is velocity in the x direction. Final for the two balls must equal the one without any collision in both the x direction and in the y direction. Now, given that and velocity is distance over time, we can replace velocity with distance over time, and knowing that the time is equal for each ball to drop, both under the influence of gravity at 9.8 meters per second squared, we can cancel out the p's, and you got the distance in each direction for the first ball, the second ball, final, in the x direction and the y direction must equal the first ball. Now, we can also look at this in terms of conservation of energy. If you remember here, 1/2 mv squared is kinetic energy. And again, I can cancel out the mass because the mass of the marbles are the same. So then you get velocity squared of the first ball is equal to velocity initial final squared plus velocity of the second ball final squared. That conservation will hold. And again, if I do the velocity equal distance over time, I can then delete out time, and you find that you have the distance of the first ball squared without the collision should be equal to the distance of the second ball after the collision squared plus the distance of the second ball final after the collision squared. So what you want to do is 5 trials, or as many trials as you need to do to get comfortable with the landing place. I'll go back to that one slide. The landing place after the collision of the two balls, as well as the before. And what I mean by before is a ball without collision, and you should be able to prove conservation of momentum.